going to write your own programs for the Sinclair Spectrum, then there are various things you'll need to know. Now, obviously, you'll have to decide what sort of programs you want to write. Games or educational programs, perhaps. You'll also need to know what the machine is capable of. Colors, text, graphics, calculations. And you'll also need to know a certain amount about the basic language, which is the way that you'll be giving your instructions to the machine. Now, if you've been through the Horizons cassette that came with the machine, then you'll have seen some examples of what it can do. You've seen examples of text and of graphics, colors and of sound. So what we're going to do during this videotape is discuss the basic language, the different statements that you're going to be using in order to get the machine to do what you want it to. Now, we won't have time to tell you everything about every statement. So you're going to depend quite heavily on the instruction book that came with the machine. We'll be able to discuss certain of the statements and give you ideas as to how to use them. But we'll always rely on you to go back to the manual to check out the details and learn those statements thoroughly. So, before we start looking at the basic language, let's take a quick look at the hardware that you're going to be using, the different parts of your computer system. Now, you'll spend most of your time looking at the screen, and so we should look at the different parts that there are in front of you. Around the edge, we have the border, which in fact is in two parts, because these two lines, which are invisible at the moment, are known as the input area. And any information that you type into the computer will go in and appear on the screen in this position. And this input area is also used by the computer to send you certain messages. Now, the part that I have colored blue here is the paper. That's the main part of the screen for displaying information. And on the paper, the information that is displayed in ink. So when we talk about the color of the paper, or the color of the border, or the color of the ink, we're always talking about these parts of the information on the screen. Now, you'll be depending upon your cassette recorder player for copying programs into the computer and saving the programs that you write, and also perhaps saving data, information that will be used by those programs. Now, I'm using a special cassette player that's designed to be used with computers, but you may find that one you have already will work quite well. And if you've been through the Horizon tape, then you will know about setting the volume level so that it works correctly with your computer. Now, your main communication with the computer is going to be through the keyboard. And at first sight, it may look a little daunting, because every key on the keyboard seems to have 5 or 6 different meanings, depending on whether you read red or green or white. But it's really quite straightforward as long as you approach it carefully. Let's look at one specific key and look at the legends that are written on that key. Now, the B key has the word border underneath it. Above it, the word bin, below it, the word bright, and also printed in red on the key itself is a star. Now, at different times, that key can produce any of those effects. In order to know which one it'll produce when you press it, we need to look at the cursor that you see at the bottom of the screen. The flashing K cursor tells us that BASIC is expecting a keyword. The keyword that's written on the B key is the word border. And if we press the B key when our cursor is flashing K, we'll get the word border. Notice that now our cursor has changed. It's no longer a flashing K, but a flashing L. This means that BASIC is no longer expecting us to type a keyword, but is expecting a letter or a number. If we press the B key again, we get a small b. We get the letter that is printed on the key. Now that is the start of a basic instruction. It's a border instruction. In fact, it's not valid, and if we press enter now, we'll see what BASIC does when we try to give it an invalid instruction. There's the enter key. We get a message, variable not found. For the moment, we'll ignore that message. We'll press enter again, which will give us our K back again. Well, let's put in a valid border instruction and see how it works. Pressing B again gives us border, and this time we're going to follow it with a number, because you'll see that the numbers at the top of the keyboard have colors written above them. Let's try a green border. Green is above the 4 key, so if we say border 4 and then press enter again, we have an immediate result. The border has gone green. If we didn't like green, we could use another border instruction, border white or 7. Pressing enter immediately returns us to our white border. Well, that's all very well for instructions that we want obeyed immediately. But if we want to put a program into the computer, then we don't want the instructions obeyed immediately. We want the computer to remember them all, so that they can all be obeyed together a little later. And if we look at the program I've put into the computer now, you'll see how we achieve this. Now here's a part of a basic program, and you'll see it's a mixture of numbers and letters. Now each of these, rem, paper, ink, CLS, is a keyword in the basic language. And they're easy to spot in this listing because they're all in uppercase. And all these small letters that you see are words that I've typed in using the keyboard. But the important thing to note is that at the beginning of each of these lines is a number, and it's called a line number. And it's because of these line numbers that BASIC knows that each of these lines is not an instruction to be executed immediately, but it's a line that's to be stored in a program. Now it doesn't matter, as in this case, that our statement in BASIC has got so long it's gone on to the next line. That's still considered to be one line of BASIC. So every line in our program has a number. Most of them go up 10 at a time. But here we've got 1 and 2 at the beginning. And BASIC uses these numbers to work out in what order we're going to put statements into the program. We'll put a border statement between this one, setting the paper, and this one, setting the ink. So we need to give it a number between 10 and 20. Let's give it number 15. We type 1 and 5, because our number keys don't have keywords on, so we get 15. Let's press the B key. We still have a flashing K cursor, and so we get border. Let's ask for a green border, and green was above the number 4. Now when we press enter, the border hasn't changed color. That instruction hasn't been obeyed. But if we look back to the list of instructions, we now have number 15, border 4. So that new line of BASIC, that new statement, has been put into our program, and the place it's been put has been controlled by the number we gave it, its line number. 15 comes between 10 and 20, and so border was put between paper and ink. Now that border statement will only be executed if we run the program. How do we run the program? Well, the R key has the word run on it. If I press the R key now, you'll see that BASIC gives me the word run. This is going to tell BASIC to execute all those statements in the program. It won't do it until we press enter. So let's press enter now. The program has started to run, and our border statement asking for a green border has given it this effect. Now we won't look at the rest of that program for the moment, because we'll be coming back to it a little later. But what we will do is look at some of the basic statements that are within that program. Now if we look at the text we can see on the screen, then the numbers we can type simply by using the number keys. These small letters we can type by using the letter keys. And some of these words that are in capital letters we can get with a single press of a key. But some of them, paper, ink, inverse, aren't printed in white on the key. They're printed in different colors around the key. And also these punctuation marks, a comma, a semicolon, a quotation mark. Now they're on the same keys as letters, but they're not printed in white. So we'll need to go back to the keyboard to see how we can get these alternative meanings out of the keys on the keyboard. Now down towards the bottom right of the keyboard, you'll see symbol shift. And because the words are printed in red on the key, that tells us that symbol shift is used to get these red symbols that are printed on the other keys, equals, plus, minus, and all the others. But that symbol shift key has to be held down while we press the other key. Let's see the effect of using the L key. By itself, with a K cursor, that gives us let. With an L cursor, pressing the same key again, gives us a small letter L. But if we hold down the symbol shift key while we press L, we get the red symbol that's printed on that key, the equal sign. So we'll use symbol shift held down in conjunction with another key to get any of the red symbols, or in some case words, that are printed on the keys. That still leaves us the problem of how to get the green letters, which are printed above the keys, and the red ones, which are printed below. And in order to achieve that, we have to go into what's called extended mode. You've seen the symbol shift used here, and this time we're going to use it in conjunction with the caps shift key, which you see at the left of the keyboard. If you watch the flashing K cursor, if I press both of these together, it changes to an E, meaning extended mode. And now, if I press a key, the meaning of the key is the meaning printed in green above the key. If I press the C key, which has L print in green above it, we get L print on the screen. Notice that the cursor has changed back to a flashing L. So extended mode will only work for that single key depression. Let's go into extended mode again. But this time, while I press the C key, I'm going to hold down the symbol shift. And now you see that the word paper has appeared. And that's the word that's printed in red underneath the C key. So we can obtain the green and red printing above and below the keys by going into extended mode, pressing symbol shift and caps shift at the same time, Then if we press a key, we'll get the green meaning above it. But if we hold down the symbol shift, we get the red meaning below it. Now we've seen how we can type some of those statements using the keyboard. Let's take a look to see how they're used inside the program and what they do. The first two statements here are called REM, R-E-M, and that stands for a remark. Really, that's not part of the program at all, but it just allows us to put whatever we like as part of that statement as a remark about what the program does. It doesn't make any difference to the way the program executes or to the numbers it's going to print out, but it's a useful reminder as to which part of the program does which part of the calculation. Border we've seen, and that's used to set the color of the border. Paper and ink are used to set the color of the paper and ink respectively. They're each followed by a number, and those numbers will correspond to the colors printed above the number key. CLS is a nice simple statement. It stands for clear the screen. So as soon as we execute that statement, the whole of the paper area of the screen will be cleared and set to the paper color. So these three coloring statements and the one clear screen statement just set up the screen the way we want it for our program. A print statement doesn't print on paper, it prints on the screen. So this information, A, body, weight, will be printed in ink color 1 on paper that's color 5. That's ink blue on cyan or light blue paper. Another print statement here, and an input statement. Whereas the print statement prints information onto the screen, we'll see later that the input statement allows you to type information in through the keyboard. Now, a program will contain many statements. We can see a few of them at the beginning of the screen here. But what if we wanted to look at all the statements in the program? Well, there's a special command we'll use called a list command, which will allow us to see all the statements in the program, not just one screenful at a time. And the list command is on the K key. If I press K now, I have list. If I press enter, well, we start with the same information that we had before. A listing of the statements in the program from the beginning downwards. But at the bottom of the screen, we have this message, scroll, ? And the computer does this to tell us that it has more information to show us, but it can't get it onto the screen. If it tried to show us the whole program on the screen, then the lines would be lost from the top. Yes, we want to scroll. We want to see more of the program. If we press the Enter key, you can see the lines of program run up the screen so that we can see the next screenful. Again, the same message, scroll. So each time we press Enter, we'll get another screenful of the program. We now don't have the message scroll, we have a message saying OK. And that tells us that that's the last line of the program. So we can use a list command to run through and see all the statements in the program. Let's do it again. List, enter. Only this time, we don't want to see any more. Instead of pressing the enter key in response to the question scroll, we press the break key. That says stop scrolling. Don't show me anymore. So we've seen how to put lines into a basic program by typing a line number and then the basic statement. And we've seen how we can use the keyboard to obtain all the words and characters that we're going to need. So before I show you a complete program, the one other subject I'd like to look at is the subject of editing, so that if we do make a mistake when we've typed in a line in our program, then we don't have to type the complete line again. We can just make a change to the line in the program. And we'll use the same program and make some changes to it. Now, beside line 15, you see a little arrowhead. And that tells us that the computer thinks this is the current line. But if we're going to make some changes, we'll do it on this line. Now we can make that arrowhead point to different lines by using the up and down arrows on the keyboard. Now they're above the 6 and 7 keys, but they're printed in white, so they behave like capital letters. In order to get up and down, we have to use the caps shift key at the same time. Now I'll hold down caps shift and press 7, which is the up arrow key. You can see the little arrowhead has moved up to line 10. Press it again, it's gone to line 2, and again to line 1. If I try to go up any further, I can't. I'm at the beginning of the program. I'm still holding down the caps shift key, but now, as I press the 6 key, you can see the arrowhead move down the screen, one numbered line at a time. I'm now on the bottom line, which is line 140. If I go down again, and the text on the screen moves up a little bit, so that the next line, 150, comes into view. And I can carry on going down. Each time, the arrowhead moves down one line. So that allows us to get to any particular line, but slowly sometimes. If we want to make a big jump from one part of our program to another, we can use the list command again. List, only this time I'm going to put a number after it. If I say list 10, list 10, and press enter, you can see that my program has been listed starting from line 10, and that little arrowhead is now pointing to line 10. Because there's more to be shown, I have this message scroll again. I'll press the break to say I don't want to scroll. Now let's suppose we want to change this line 10. Instead of saying paper 5, we want to say paper 7. I could just type the line in again, 10, paper 7. But you'll see above the number 1 key the word edit. Again, it's printed in white, so if I hold down caps shift and press edit, then we have a copy of line 10 transferred from the current line down to this input area. And there's a cursor in the middle of it. The line is still in our program, but now we have a copy of the line that we can make changes to. Again, we use the arrows from the keyboard, but this time we want the left and right arrows, which you see above the 5 key and the 7 key. Printed in white, so we must hold down the caps shift. But if I hold caps shift and press 8, my flashing cursor has moved from in front of paper to following paper. Press it again, and it goes past the 5. Pressing the left arrow key, still holding down caps shift, I move back towards the left. So by using 5 and 8, which are my left and right arrow keys, I can go to any part of the line that I want to. Now, I wanted to change 5 to 7. To do that, I have to delete the 5 and then type in a 7. And you'll see that above the 0 key is the word delete, printed in white. So if I hold down the cap shift and delete by pressing the 0 key, the 5's gone. My line now just says 10 paper. I can type in 7, and now I have line 10, paper 7. What I need to do now is to take this line and put it into my program, replacing that one. All I have to do is press Enter. You can see the result. Line 10 is still the current line. I have my little arrowhead there. But now the new version of the line, paper 7, is in my listing. The old one, the one that said paper 5, has gone completely. To show that this really worked, that my program has been changed, let me run it again. Pressing R for run, followed by Enter. The program comes again, but this time the paper is white, which is color 7. We've now recorded onto the soundtrack of this video cassette a computer program which you can copy onto an audio cassette and put into your own computer. And this will give you some practice at using the editing and keyboard facilities that we've been discussing. And after you've played with that program and had some practice, then we'll come back and look at the writing of a complete basic program. Well, let's run this program, see what it does, and then see how it does it. Well, the first thing we see is that information is printed at the top of the screen. First two lines are in dark blue on light blue, and the third line is printed with the colors reversed, light blue letters on a dark blue background. Now down here, in the input area, we've got 3 lines of printing. Because I've asked for several things to be printed down here, this input area has got bigger. It's moved up the screen a little bit. And we're being asked to press M if we're male, F if we're female, and then to press the Enter key. A flashing cursor here, between quotation marks, tells us that we're expected to type in some characters of some kind. Well, let me type an M, and you can see the M appear, and now I'll press Enter. The result of that is another line has appeared at the top here, saying, I'm male, and we are being asked another question down here. Now this time we're being asked for a number. Type your height in centimeters. Notice we have no quotation marks around the flashing cursor now. This tells us that a number is expected. Well, let's put 200 as my height in centimeters and press Enter again. The information has been repeated up here, so the number we typed in has been put up in this part of the screen, and we have another question. Am I slightly built, S, medium build, M, or heavy build, H? Well, let's put M for medium. Press Enter. 2 more lines on the screen. Again, medium is as a result of what I typed in. The 80 is the result of the calculation. The program has calculated what it thinks I should weigh. And notice that that 80 is flashing. At the bottom here, we've got a message saying OK, with a number in front saying 0. This tells us that our program has finished, and finished correctly. 440 is the number of the line in the program where we finished. So the program has taken in 3 pieces of information. We typed M for male, 200 for the height, and M again for medium build. As a result of those 3 pieces of information, the program has done a calculation and has come up with a number 80. All the rest of the information you see on the screen, the whole of the first 3 lines, and most of these 4 lines, is constant information. It'll be the same every time the program is run. Well, that's what the program does. Let's now take a look at the statements we used to do that. If we list the program, we can analyze the statements we used. Paper and ink we've seen used before, simply setting the paper and ink color. Clear the screen. So let's look at these 2 print statements, which printed the very first 2 lines of the heading. Print at 1,8. The print statement says put information onto the screen. If I follow it with at 1,8, I mean position 8 on line 1. Line 0 is at the top, so the second line is line 1. Position 8 is about there. So a body weight, which I've put inside quotation marks, will be printed along that part of the screen. Anytime that we want to print fixed information, information that's never going to change, we can simply put quotation mark there and a quotation mark there. Whatever we put between those quotation marks will be printed. In the same way, the next print statement prints at line 2, position 9. So line 2, position 9, the word calculator. Now this print statement printed out don't believe the figures. But they were printed out in reverse printing. Instead of dark blue writing on pale blue paper, it was the other way around. And that's because of this line. Line 60 says inverse 1. Now after I've written that statement, any print statements that occur will be printed in inverse printing. So instead of ink color printed onto paper color, it'll be the other way around. Paper color printed onto ink color. Line 80 changes it back again. So we've only got 1 print statement being used to show us inverse printing. Now the first thing the program did was to input a value. Let's look at this input statement. Input says we want whoever is using the program to type a value on the keyboard, and we want that value to be put into the program. I put input and then followed by quotation marks all this information, because you can't ask somebody to type something in unless you tell them what it is you want typed. So this information was all printed in the input area before we were ready to type our information in. But after all that, after then press enter, I put a semicolon, an A, and a $. Now the $A is not something that's to be printed. There are no quotation marks around it. $A is the name of a variable. We said something's going to be typed in on the keyboard and it's going to be put into the computer. Put it in part of the memory and call it $A. The $sign means it's going to be just a string of characters. It's not going to be a number. So we're not going to do any calculations with this. If you remember, the first thing we typed in was an M for male and an F for female. Just a single letter followed by enter. A single letter followed by a $sign is the name of a piece of storage where we can hold a string of characters. For example, one letter. Now later in the program we're going to use $, again, because we'll want to see what character we typed on the keyboard. This happens in the next line. If $, is equal to M. Now here we're asking a question about that character that was typed in. We're saying, is the value that's in the variable $, an M? If asks a question, and it will only do something if that gives us a true answer, a yes. So if we typed M in response to this input statement, then the if here will give a yes. Is $, equal to M? Yes, it is. We did type an M. The next statement, if $, is equal to F, asks another question about the same variable. Was it an F that we typed in? M and F were the two values that were expected by the program. $, in the same way, is another variable. Because it's got a $, after its name, it's going to be something that's going to hold characters. Whereas with $, we put a value in there by typing it in an input statement. A let statement allows us to put whatever value we like into that variable. I've said put M-A-L-E, the word male, into the string variable $. Quotation mark there and another quotation mark there means that this is a constant value. So this let statement will always put the four characters M-A-L-E into $. So if we've got $, having a value of M, then $, will get the value male. Similarly, if $, is an F, if we typed an F in response to this input statement, then $, will get the value female. Remember, just because a line wraps round one end of the screen and appears again at the left-hand side, it doesn't matter. It's all one line. Up here we have another let statement. Now what did we put into $, here? We put nothing. Quotation mark, quotation mark. We said put into $, no characters at all. Why did we do that? Well, if we entered an M, then we put male into $. If we entered an F, we put female into $. But if we made a mistake and something different went into $, we don't get male or female put in there. $, will still have nothing in it. If $, has got nothing in it, that will be true. Then go to 100. So an if statement can make us jump to another part of the program. That means line 100. Where's line 100? There it is. We'll go round again. Let's run the program to see if that works. Here's the first question. Press M or F. Well, suppose I press D. It's neither M nor F. When I enter that, I get the same question back again. The program knows it isn't an M, it isn't an F, and so it asks me the question again. Now, we won't go through all the individual statements that make up the rest of those questions and answers, because you'll be able to look at them yourself when you copy the program into your own computer. What we will do is look at the end of the program, where we do the calculation of the body weight and we print the final answer. These are the last 5 lines of the program. Line 400 is another let statement. It's going to do a calculation here and put the result of the calculation into my variable called W. Now, h is the height in centimeters, and we set that by inputting h. I'm multiplying it, and that asterisk is used for multiply, by 0.4. The next 3 lines, 410, 420, and 430, do further calculations depending on the other information we put in. If we put in F for female, then $S will be female. And what we do is take the value of W multiplied by 0.8 and put it back into W. So W becomes 4/5 of the value it had before. Similarly, if we're of heavy build, W equals W plus 6. We add 6 to W. And for slight build, we subtract 6 from W. So these 4 statements all put values into W. This an initial value, and then these 3 will change the value of W. And our final print statement, printing at 11.5, line 11, position 5, the words "you should weigh" W, that's the value we calculated, kilos. And around W, we've put flash 1 and flash 0, with semicolons separating the flash, the W, and the characters we wanted printed. Flash 1 says start flashing. So anything after this flash 1 in this print statement will be printed flashing. That's W, the weight. Flash 0 will switch it off again. So kilos will not be printed flashing. And in fact, we can emphasize text in another way by using bright instead of flash. Let's show the result of that final print statement using bright. There you see the result of replacing flash by bright. The number has been printed in a brighter form. And we can see the statement that did that by listing line 440, bright 1 and bright 0. Now we've looked at a lot of different statements in this program, and there are a lot of statements that we haven't had time to discuss in detail. So it's very important that you copy this program into your own computer and spend some time looking at it, seeing how we've used those statements, how we've assembled them together into a complete program. When we come back, we'll look at some more aspects of basic programming. Well, as you can see, the Sinclair Spectrum is quite capable of scribbling all over the screen. We're going to look at some of the statements that can be used to produce graphics on the screen. There are 3 main ones that we'll be looking at, and those are plot, draw, and circle. But before we look at the individual statements, let's take a look at the screen as it's used when we're using graphics. Now we have to think of the screen slightly differently when we're using graphics. Instead of thinking of this as being line 0, character 0, we have to think of the bottom left of the screen as being the point whose address is 0, 0. any point on the screen is identified with two numbers. One, its distance from the left-hand side, and the other, its distance up from the bottom. From position 0 at the left, we can go up to position 255 on the right. From position 0 at the bottom, we can go up to position 175 at the top. Let me give you some examples of those. So the point in this position is referred to by the numbers 128, 88. 128 across and 88 up. The point in this position here is 200 across from the left, 150 up from the bottom. So its two coordinates, the two numbers that identify it, are 200 and 150. The first two statements we'll look at are plot and draw. Now the plot statement takes us to a certain point on the screen and plots a single point at that position. And the draw statement, at least the simple one we'll look at first, will draw a straight line starting from that point. We can see that in this very simple example. Here we have two lines that have been drawn on the screen. And if I list the program, which is only 3 statements, you'll see the 3 statements that did that. This is the point 100, 100. 100 from the left and 100 from the bottom. So line 10 moved to that point on the screen and drew a single dot. Now, the draw statement started from that position and drew a straight line which was 10 in that direction and 10 in that direction. So we got a diagonal line. The second draw statement carries on from where the first one left off. It's going 10 in that direction again, but we've got minus 10 here. So it'll draw in a downward direction. And so we get a line that slopes like this. Now, one nice thing about the difference between plot and draw is that we can use plot to take ourselves to any particular point on the screen and then draw relative to that point. This means we can set up a series of draw statements to define a shape and put that same shape in several different places on the screen by plotting to different points first before we execute the draw instructions. You see a very simple example of that here. Now, these 4 draw statements will draw a square. The first one goes 10 to the right and 0 up or down. The second one doesn't go to left or right, but does 10 upwards, and so on for the other 2. If we run this very small program, we'll see the square, a small square in the bottom left-hand corner of the screen. But we can use those same 4 draw statements to put that square anywhere we like by putting a plot statement in front of them, like this. So to get my square positioned here on the screen, I simply need to put in front of my 4 draw statements a plot that takes me to a suitable position. Plot 100, 100 takes me to this bottom left-hand corner, and then the 4 draw statements will go round the square. But suppose I wanted to draw several squares, or repeat the same shape several times on the screen. I don't want to repeat the same draw statements over and over again. And so this seems to be a good point to bring in the idea of a subroutine. And in the next piece of coding, you'll see what a subroutine is. So if we look at this coding, we see our 4 draw statements as before. After them, there's a new statement called return, and we'll see why that's there in just a moment. We have 3 plot statements, plot 100, 100, as we had before, plot 80, 20, and plot 0, 150. So these 3 plot statements will plot points at 3 different parts of the screen. And after each plot, I said go sub 1000. Now this go sub statement together with this return statement, make this set of statements in our program into a subroutine. When BASIC reaches this go sub statement, it jumps to line 1000 and starts executing the statements there. When it reaches the return statement, it jumps back to the statement after the go sub. We execute this second plot and we go sub 1000 again. So once more we'll jump to this point, execute our draws and return. But this time we'll return to here. Another plot to move to yet another point on the screen and another go sub. So although we've only coded these 4 draw statements once in the program, they'll in fact be executed 3 times. Once after this plot, once after this plot, and once after this plot. And if I run the program, you'll see how it works. Very well. Our 3 plot statements have taken us to these 3 different points on the screen, and after each plot, we've drawn a square. So a subroutine is very useful if we have one piece of coding that needs to be repeated many times at different points in the program. Now, as you go on and write larger and more complicated programs, you'll find that this idea of subroutines becomes more and more useful, not only because you can repeat the same section of coding from different parts of the program, but also as an aid to breaking up the program into easily manageable parts. And you'll see, when you look at some more complicated programs, how they have been divided into subroutines. However, let's return to our draw statement and see how we can persuade it to do bent lines. Here's that same program again, but I've made one small change. I've added a third number onto this draw statement, comma 3. Now if we put 3 numbers into a draw, the third one is used by the computer to decide how much the line should curve as it goes the distance determined by the first 2 numbers. If we run this program again, we'll see the result of that. Each of our little squares now has a slightly bent top. And we can change the curvature, make it larger or smaller, by changing that third number in the draw statement. Let's try something much bigger. Here I've changed the number to a 5. And if we run this again, we'll see the result. It's got to go through 5 radians, as they're called, of curvature to get from the beginning of the line to the end. And the bigger we make the number, the more it has to curve, up to a limit of just over 6, when we'd be getting a gigantic circular shape. See what's happened to this square. Although the first 2 lines were drawn successfully, as it curved round to do the third line, it came off the paper into the border area. And at the bottom of the screen we have this message, integer out of range. And we'll always get this message if our drawing tries to go off the main part of the screen. But of course, if we want to draw complete circles, then we have a separate statement that'll do that for us. The circle statement. I drew 3 circles on the screen using 3 circle statements. The first 2 numbers in the circle statement are the coordinates of the center of the circle. So the first one and the third one have both got a center at 100, 100. And so these are concentric circles. The third item is the radius of the circle, the size of the circle. 20 for the inner one here, and 70 for the outer one, and 10 for the small one in the corner. So we can draw partial circles using draw. We can draw complete circles using a circle statement. So those are our basic graphic statements. Let's go back to that scribbling program you saw at the beginning and see how I wrote that. Now the scribbling looked random because within this coding we have the randomized statement and the RND function, which are the two facilities the spectrum gives us for putting random numbers into our program. If I run through this coding and show you how it works, you'll see what use I've made of those random numbers. I've started with a plot statement, 128, 88, which is roughly in the middle of the screen. And I'm using the variables x and y to remember my current position. So I've set them to 128 and 88. Now yy and xx are being used to find a new point on the screen to draw to. I've chosen random values for them somewhere on the screen. This draw statement calculates the distance I have to go horizontally and vertically to get from my first point here to the new point I've just worked out. And here I put into x the value of xx and into y the value of yy, so that I remember how far I've drawn to, because that's going to be my new starting point for the next draw. Here I go back to 50, think of a new random point to draw to it, and remember it in x and y. So as I go round and round this coding, I'll keep drawing lines to random points on the screen. Now the RND function gives us back a number between 0 and 1. It can be as small as 0, but it will never be quite as big as 1. So this value, RND times 170, is going to give us a number between 0 and 169. And that's the value we're putting into yy. RND multiplied by 250 will give us a random number something between 0 and 249. And so that's the value that's going into xx. As we execute these statements over and over again, we'll get different values out of RND each time, which is why our line zigzagged across the screen. I put the randomized statement in at the beginning, which makes sure that each time we run the program, we'll get a different set of results. If I left out that randomize, I'd get the same values returned from RND each time the program was run. Randomize makes sure that they're different every time. Now we can use paper and ink with our graphic statements in the same way as we did with our text printing statements. But there is one thing that we do have to watch. In each character position on the screen, you can only have one ink color and one paper color at the same time. You'll see what I mean if you look at the screen now, where I've run the program again, but this time with color. It looks quite pretty at first sight, but if we look more closely, we'll see what's happened. This was a yellow line, so the ink color in all these character positions was yellow. But we crossed it with a black line, and the black line was making all the ink colors black. So this little part of the yellow line that's sharing a character position with black has gone black itself. So we have to be very careful when we're designing colored graphics to keep our colors in separate character positions wherever possible. Now we haven't had time to cover the whole of BASIC in this videotape, but I hope we've covered enough to give you a good start along the road of writing your own programs. But it is most important that you look at the programs that we've given you, the ones we've recorded on the videotape, to see how we've constructed those programs and how we've used the different statements within them. And then when you've looked at the statements, check them yourself in the manual to make sure that you understand exactly how they work and how you can use them. And in later videotapes in this series, we'll carry on with learning BASIC.